Thank you for the opportunity. I feel I'm very fortunate to come to Krakow and meet so many people and work here, give this seminar to share some of the ideas and some of the things that we have been doing at Curtin. So today I want to talk a little bit about a teaching strategy that we introduced about 12 years ago, and now all our first year classes are taught in this sort of way. The problem we needed to fix, one of the things was we found that when we were giving our lectures, the students were not really engaged in their learning. They were just sitting there half paying attention, and that's all. And we weren't challenging them to think. We were telling them what they needed to know, but not think about what they needed to know. And unless you think about it and how it works, you don't actually retain it. Really taking a responsibility for their learning. Some of them were coming to classes, but they weren't actively involved. And that meant that retention was not so good. We also knew that the research has clearly shown that the didactic approach is not very effective. Students, we don't learn very much from lectures unless we take something away or do something with it. Just sitting there listening to someone talk for 45 minutes doesn't necessarily teach you anything unless you can actually link it and with something you already know or process it in some way. And we weren't really enjoying what we were doing as teachers, because we felt like we were talking to nobody, a bit like teaching during COVID, and we wanted to change also the mindset of our colleagues to change the way they teach. And I think in many respects we've done that reasonably well. So I introduced this talk at the conference on Monday, this triangle, and yesterday for those who are at the workshop. These are this sort of triangle as there, and there's debate about the order, and but I think most people tend to agree that the things at the top do not require a lot of effort. They are very passive type activities, and you retain less from those sort of activities, whereas the activities at the bottom require significantly more effort, more cognitive involvement, and consequently you retain more if you participate in those sort of things. And we've classified those as passive learning, the top half of the triangle, and active learning at the bottom half. And that's what we would like to get our students to do, be more active in their learning. And there are many active learning pedagogies or processes, and you've probably seen and heard of many of these: cooperative learning, collaborative learning, peer-led team learning, peer instruction, guided inquiry learning. POGLE is a combination, process-oriented guided inquiry learning, and there are many others as well. Problem-based learning, I think you've done a little bit with before. There are other strategies, and the other strategies can be quite useful in that they don't need to change the pedagogy as much, that they're in some respects easier to implement into your class. Having the students do a reflective diary, ask them to tell you what they think are the 3 most important take-home messages from your lecture. Getting them to think about it, getting them to summarize it, brings it into that they have to think said and try to prioritize. If you tell them, it doesn't have the same effect. Concept maps are a wonderful way of getting students to tie knowledge together and concepts together and so they can see the link. So instead of having many different facts, they all tie together and it becomes much easier to navigate. The muddiest point is something that may not be so clear, but the concept there is to ask the students, in today's lecture, what was the least clear? So again, they have to reflect on what you've said. And if you do something like the muddiest point, at the end of your lecture, invite the students to post on a discussion board what they thought was the least clear aspect of the lecture. And then you can have a look at that. The next class, spend 5 minutes addressing maybe the top 2 or 3 points. And that's one way of getting the students more involved in their teaching, but also giving them the message that you are keen to help them learn. So it's good for their perception of your interest in their learning. Okay, so what is POGLE? POGLE is process-oriented guided inquiry learning. And the idea here is that we will provide some information, and then we give them a series of guided inquiry questions to help them interrogate that data, help them find patterns, help them draw conclusions and trends, and ultimately either write a summary or a conclusion on what's going on in this data set. And by doing that, we are developing a whole pile of process skills with the students. And these process skills are really important and often not addressed very well. So the process skills that POGLE is trying to develop are oral and communication skills. The students are working in teams typically of 3 or 4 students, and so they're working together. So there's teamwork. They need to talk to each other. They need to write answers to the questions. In POGLE activities, we often ask them the question and say, as a group, write a grammatically correct sentence to explain. We find that if they're writing a proper sentence, not just the key words, they actually have a better conceptual understanding than just sometimes just throwing the key words down. They think they know what they mean, but they don't know how they link, etc. So if they write a full sentence, then it's a bit more challenging, and they're developing their written communication skills. During POGLE, they learn how to solve problems because they learn how to interrogate data. They have the critical analytical thinking. Again, it's part of interrogating the data, looking for the information provided, looking for patterns. They're working in teams, so there is team and self-management. Obviously, they're processing information that's provided, and they also need to be able to assess themselves, their team, and they have an idea of whether the quality of the work they're doing is appropriate or not. And so these skills are developed. But I don't know so much in Poland, but in Australia, it's not often that we actually, where do the students develop these skills? I prefer the question, when do we give students the opportunity to develop these process skills? And before POGLE in Australia, in my classes, certainly in my university, it was kind of expected that it happened, but it was never a target, never actually part of the curriculum. This is one of the things that POGLE is doing, and because it's part of the learning process, they are developing those skills in that process. I'm hoping that you can still hear me. The way we run the POGLE process is I typically in my class would use 3 people because we typically are in lecture theatre, so they're sitting in rows. The recorder always sits in the middle. and the manager's on one side and the presenter is on the other. And the manager focuses or manages the group to make sure everyone's working appropriately. The recorder keeps the official record of the answers that is then shared amongst the 3 team members. Questions or answers questions. And we limit the questions to the presenter only for a couple of reasons. One reason, when we've got a class of 30 students in my workshop, we run this workshop with 150 or 200 students, but then we still have one teaching person per 30 or 40 students. So when you've got 30 students under your care, if they're working in groups of 3, there's only 10 groups to work with. So you can communicate with them a little bit better. The other advantage of having only the presenter ask the question is that before the presenter can ask the question, for example, in the group, if the manager does not understand something, the manager needs to discuss what he or she does not understand with the group, and if they still don't understand, then the presenter can ask the question. By doing it this way, often the problem is solved before they have to ask the teacher. And the teacher tends to work on the basis that we don't give the answer to the questions, but we answer the question with another question. Guide them to work it out themselves, because most of the times they know, but they don't know where to look. On some occasions, we will have teams of 4, and when I was working with my colleague in Korea at the school, her class was set up in teams of 4. So we had a 4th person who was the reflector or the coach. So the manager made sure the work was being done. The reflector made sure that everyone was participating in the activity. And these roles changed every day. Every lesson, I would reassign the group. So, for example, in the first lesson, the person whose birthday was first in the year was the manager, second in the year was the recorder, third in the year was the presenter, and then the next day I changed those roles. And we do this because everyone needs to learn to develop these skills. If we let the students choose, the person who hates to speak out in class will never select presenter, and therefore never gets the opportunity to develop those presentation skills. So if we move it around every time, they all get to do this, and it's not a traumatic experience. Okay, the way POGIL works is that we provide them with data or some sort of information. We often refer to it as a model, and then through a series of questions, we get them to interrogate this model. Look for the trends, look for the patterns. And at the end of those questions, they should be in a position where they can either summarize the key concept, understand the concept. They may not know the concept's term, but they understand the concept itself. This is the evidence that convinced me that this was a good process. In this university, there were two streams for organic chemistry 1. One stream was taught by a lecturer who used the traditional method. The other stream was taught by a lecturer who used the POGIL method. At the end of the semester, they did the same exam, pretty much similar. The following semester, those who continued in organic, there were less, so there was only one teacher running the program, and this teacher did not. All the people passed organic 1, and the teacher wanted to know what have they learned from the previous semester, so gave a surprise pre-test on the first class to get an idea of what are the key concepts that they understand or not understand. What he found was, or she found, was that the results were quite surprising. Those people who were taught by lecture mode, and that's the black bars, 60% failed on these fundamental concepts, whereas only about 25% of the POGIL people had failed. Of the POGIL taught people, more than 50% scored 70 or more. Now, if you take into account that chemistry, like many other sciences, we construct our knowledge by building it on knowledge we already know. If you have a poor foundation knowledge because you've forgotten it all, trying to learn organic 2 is going to be much harder for those people who scored less than 50% than those people who scored more than 70%, because those people who had scored well already had a good foundation to build new knowledge on. People from scratch, and their new information is not being linked to old information, and it becomes more fragmented, and consequently their learning is not as good. So this slide was the slide that convinced me that POGIL was something I want to use. This is an example, I don't need to use this slide, of what we have done and how I've developed it. Research has shown that a problem with organic chemistry with a lot of students is they don't understand some of the language conventions, the pictorial language conventions, the way we draw structures and the way we represent mechanisms in organic chemistry. So we developed a couple of activities. This is one of the sample activities that I have used. So what I do is give the students this information. So they've got the molecular formula, the condensed structure, the Lewis structure, and the line structure. The line structure is what we tend to use in textbooks in the university. The Lewis structure is what they would have seen at school. And so most of them are reasonably comfortable with the Lewis structure, but they don't know and understand the line structure. And so I went through a series of questions, fairly simple questions. In the structures, what did I think most can clearly see or would know that the lines represent bonds between atoms. How many bonds does each carbon atom form, as shown in the Lewis structure? So they can all count to 4, and they see every carbon atom in the Lewis structure has 4 bonds. Carbon atoms are not usually shown in line structures. What features in the line structure represent carbon atoms? So again, comparing Lewis structure with line structure, they come to the conclusion that the end of every line is a carbon atom unless something else is written there instead. So like on the first one, we have an OH, so the end of that line is not a carbon, but an oxygen. And so they can work this out. Very few hydrogen atoms are shown in line structures. Under what circumstances are they shown? So they look at it again, compared to in the line structures, the only time we see hydrogens is when they're attached to an atom that's not a carbon. In the line structures, how do we know how many hydrogen atoms are in each carbon atom? Well, they've already answered that carbon forms 4 bonds. They've already answered that the lines represent bonds. So 4 minus the number of bonds gives it a number of hydrogens. So they come to that conclusion. And then ultimately, this is the most important aspect, is that as a group, within your groups, discuss the rules and conventions for using line structures. So they write their rules. Writing their own rules, they cement their understanding of how to use these representation style, but they also, in that same process, are learning, developing communication skills and analytical skills in putting this information together. We then give them a reference to the textbook to say they can check that your rules coincide with the one in the textbook. Before doing it this way, I used to go through what was in the textbook, explain how it worked. It was not retained. Many students still did not understand. So this method seems to work better. The other process that causes great difficulty is the concept of curved arrows with mechanisms. This is particularly common for organic chemistry. And I use here an example that they all already know. They know that you dissolve HCl gas in water, you form hydronium ions and chloride ions. It dissociates completely. And then I use that known reaction, and reaction I understand quite well, to represent that with the curved arrow mechanism. We have to be very careful when we use our language here. I tend to like to make sure you're saying that the water molecule is providing a pair of electrons to form a bond between a hydrogen ion and an oxygen, a hydrogen atom and an oxygen atom, and the electrons in the hydrogen-chlorine bond are then transferred to the chlorine atom to form a chloride ion. If you describe it that way and you're reminding the students that the lone pairs are providing the electrons to form the bond, they tend to help them. We often will say that we use terminologies like the water molecule comes in here, and it gives them the impression that we're talking about atom movement, not bond forming and bond breaking processes. But here we ask them a serious question like, in the equation above, which bond is broken, which bond is formed? That's an important process of trying to work out mechanisms anyway. Which curved arrows depict these processes? And how many electrons are involved in a single covalent bond? Where did the electron in the OH bond come from? So here, this is the things that causes them problems, and that why does the oxygen suddenly have a formal charge plus? So they, instead of the hydrogen having the formal charge, and that's where they often want to put it because they think of it as a H+. And that helps them determine where the electrons are coming from and going in these bond breaking and bond forming processes. Having done that, we give them some activities to classify whether things are bond breaking or bond forming, and this is a fairly easy activity. But then they move on to predicting the products. So the first one, use curved arrows to show this process. If they've understood the process, the curved arrow is starting from the nitrogen and going to the hydrogen. If they haven't understood the process, then they have the curved arrow going from the hydrogen to the nitrogen. But they tend to get this right. And then ultimately, given these reagents and curved arrows show the products, so being able to predict what these curved arrows are going to present. And again, the product here where you've got a protonated alcohol is something that they're not comfortable with, but they recognise the process and they seem to be okay. From the research done with my students, they found that having worked through these activities, 8% of the students still struggled and they had poor understanding in that they were drawing the curved arrows incorrectly and they couldn't describe appropriately what was happening. 63% had a moderate understanding. Most curved arrows were drawn correctly, or they had appropriate explanations. In most cases, they were better at drawing the curved arrows than providing the explanation, and 29% were actually demonstrated good understanding with both correct arrows and correct explanations. We also implemented Hogel into our large first-year class, introductory chemistry class. This is for students who have not studied chemistry at school. Most of them don't want to study chemistry. They are majoring in another discipline like ecology or agriculture or geology, but they need some fundamental chemistry to help them understand the principles associated with their discipline. So students majoring in chemistry, they're all majoring in other areas. The way we taught this subject, we had one lecture a week, which gave an overview of the key concepts, a 2-hour workshop, and that workshop is they work through POGL activities for the 2 hours to develop it. And then they also had a laboratory class, 3 hours per week. The details of the findings can be found on the reference here if you're interested. When we ran this activity, we had some research questions and we were interested to know what are the undergraduate chemistry students' attitudes towards chemistry before and after POGL? What are the undergraduate chemistry students' levels of efficacy with regards to chemistry before and after POGL? Now, efficacy is their confidence in their ability to be able to do. And third is, what are the undergraduate chemistry students' learning experiences in chemistry before and after the intervention? We use these instruments to collect the data. So you can chase those references up if you're interested in doing something similar. But what we did was that the attitudes towards studies of chemistry told us that the students found that chemistry was accessible and emotionally satisfying when they worked through the POGL activities. Now, for us, that was quite an important outcome, in that these students typically did not want to do chemistry and were afraid of chemistry. They had this scary image, but having worked through POGL at the end of the semester, they find that emotionally satisfying and accessible, meant that at least for those students, chemistry was something that was now not so scary, and now something that is worthwhile to study. With the chemistry attitudes experience questionnaire, their self-efficacy had improved, so their confidence in their ability to learn chemistry had increased. So they were more prepared to try. If you're more confident that you can learn it, your preparation, your willingness to have a go is better. If you don't think you're going to learn it, you often don't even bother trying. So in our conclusions for the first research question, we found that there were improvements in intellectual accessibility and emotional satisfaction. So the students were thought it was doable and it was satisfying, which again, this is an important outcome for this cohort of students. Again, the largest group we have, but also the poorest background. And for the research question, to the students' improvement in students' belief of the perceived control of learning chemistry. So they believe that they can actually take control and learn this process. For the research question 3, students' learning experience, the students appear to have developed positive feelings about their ability to perform in chemistry classes. And for this particular cohort, had never had chemistry at school. It provides a positive, effective experience to students who are new to the discipline and who undertake courses with limited discipline-related prior knowledge. So it worked very well for the students who had not done chemistry before. We already use it for our major students, and that it works well for them as well, but we didn't study those in this research project. A couple of quotes from some students. I've got to move my screen. I thought it would be risky depending on ourselves, but then I realised that there was no better way to learn chemistry than practicing it ourselves, from one of the students. And another student, after several months of hardship, my view for the POGL exercises changed because it helped me a lot and I could understand the topic better while referring to them. And this is something that's the second point, has come through with a number of studies that with the POGL, part of the process is learning how to learn. And if you only do one POGIL activity, it's a slow process because they take a long time, the first ones. But once you've been doing it for a while, the students learn how to interrogate the data. They learn it becomes in some respects easier because the students already know how to work in a POGIL mode. If it's immersive. A one-off POGIL activity by itself is a slow process, but a POGIL activity after they've done a slow process because they know what they're doing and they can bring that information together. I was asked yesterday at the workshop, this process seems to take time. What do you do about time management? And the answer is yes, it does take time, but as they progress, they learn how to work in this mode. And for example, when I'm teaching, I spend a lot of time on the introductory aspects of the organic chemistry, but when I'm teaching carbonyl chemistry carboxylic acids, in the old days, they were 5 or so classes. Now I do one class for aldehydes and ketones and one class for carboxylic acids because they can already see the patterns. They can already bring the information together. And so the POGIL activities work very well because they've already learned the skills previously. Okay. I think that's the end of my presentation. I was asked to talk for 40 minutes, so I'm a little bit longer. I would really like to hear some questions, comments, even criticisms, because that's how we learn.